Okay, so this is the first part of the lecture on overview of artificial intelligence. So the foundational concepts, artificial intelligence, this is when computers or machine try to think and learn like humans. Think and learn like humans. Think and learn like humans. They can solve problems, make decisions, and sometimes even understand language. So solve problems, make decisions. Okay. Now AI has been around for many years. People have been trying to make machines. So this is the history of AI. First, it was the definition, a simple manner. Now AI has been around for many years. People have been trying to make machines smart since the 1950s. And sometimes progress was very slow, which we called AI winters. But other times there were great leaps forward. Now, the philosophy of AI, this is about big questions like can machines really think? What does it mean to be intelligent? So, these are the questions dealt in philosophy of AI. Then, strong versus weak AI. Strong AI is machines that can truly think and understand just like humans. And weak AI is machines that can perform tasks that seem smart but don't have real understanding. So that is weak AI. Now, symbolic AI versus connectionist AI. So, symbolic AI uses clear rules and symbols to make decisions. So, that is symbolic AI. And connectionist AI, it works like a brain with lots of connections like neural networks. Now, Turing test. Turing test is to see a test to see if a machine can pretend to be human so well that other people can't tell that it's a machine. Now, the Chinese room argument is an idea that even if a computer seems to understand language, it might just be following rules without really understanding it. That is very, very important. Now, the branches of AI. So, the branches of AI, machine learning. When computers learn from data and get better over time, learn from data and this getting better over time. So, learning and getting better. So, that is machine learning. Now, what is deep learning? Deep learning is a kind of machine learning. It is a kind of machine learning only that uses networks similar to our brains to understand complex things. Now, natural language processing, this helps computers understand and talk in human languages. Then, computer vision. When computers can see and understand images and videos, like recognizing objects, see and understand images and videos, that is computer vision. So, robotics, so building robots that can perform tasks physically, sometimes using AI to make them smarter. Now, expert systems, computers that use a lot of knowledge to make decisions like an expert. in a field. It's in a particular field. Now, fuzzy logic is a way for computers to handle uncertainty, like things that aren't just yes or no, but somewhere in between. So, this is very, very interesting. Evolutionary computation. Computers use ideas from nature, like survival of the fittest, to solve problems. Evolutionary computation. Now, knowledge representation and reasoning, ways for computers to store information, how they are storing the information, and how they are using it. Okay, to think. Knowledge representation and reasoning. Then, planning and scheduling. Computers figure out the steps needed to reach a goal. So, computers are figuring out the steps needed to reach a goal. Now, reinforcement learning. Computers learn by trying things and getting rewards or corrections. So, they are trying things. Cognitive computing. Computers that try to mimic how the human brain works. Ambient intelligence. Smart environments that can react and adapt to people. Smart environments that can react and adapt to people, like a house that adjusts the temperature for you. Smart environments that can react and adapt to people. Now comes machine learning. So in super machine learning, there is supervised learning. The computers learn from examples where the correct answers are given. In supervised learning, there is classification, sorting things into groups, like sorting fruit into apples and oranges. Then regression is there, predicting numbers, like guessing how tall a plant will grow. Then comes unsupervised learning. Computers find patterns in the data without given answers. So here is clustering, grouping similar things together, very powerful method. Dimensionality reduction, simplifying data by focusing on important parts. Now comes semi supervised learning. It combines both labeled and unlabeled data for learning. Reinforcement learning, learning by trying actions and learning from the outcome. So there is model based reinforcement learning. The computer builds a model of the environment to learn. Model free reinforcement learning. The computer learns from trial and error without a model. Then comes transfer learning, using knowledge from one task to help learn another. Now, online learning is the learning continuously as new data comes in. This is very, very interesting. Active learning, the computer chooses what data it wants to learn from. The computer chooses what data it wants to learn from. This is also very, very interesting. Now, incremental learning, learning little by little over time. Then, meta learning, very interesting, learning how to learn better. So, this is fantastic, learning how to learn better. Now, automated machine learning, AutoML, so automating the process of applying machine learning. Few shot learning, learning from very small amount of data, zero shot learning, recognizing things that computer hasn't seen before. So we'll cover the deep learning in the next lecture, next part of the lecture. Thank you very much.